Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to get into ExScan Pro, and in this case, we're going to talk about aligning scans, in this case, aligning the point clouds, creating a mesh, processing the mesh, and aligning it to a coordinate system. Now, I've actually recorded this video once or twice already, and I decided to do it a little bit differently to try to minimize the amount of time we're going to spend here so we don't have an hour to just sit here and watch me go through this. So I'm going to try to cover the main points and get to the end as quickly as possible, but there are a lot of things to cover. So first, I'm on a different computer than I was for the scan. So now I'm at my desktop, which has a lower graphics card than the laptop, but a higher processor speed. And what I've noticed with ExScan is that it really likes a higher CPU speed. And in this case, in the desktop, it's actually using the GPU quite a bit more, even though there's less of a GPU in this machine. Now, I think with laptops, sometimes you run into the issue where they have onboard graphics cards and the aftermarket card, in my case, the Quadro P4000, will run through that graphics card, and it has a harder time actually accessing the GPU, even though all the settings in the laptop are dedicated to using that. So we're going to try this on the desktop, see if it works, but I wanted to come in here and I wanted to talk about the entire process of the scan. Now, we've already gone through the scan twice. We did the handheld HD and we did the rapid scan. I want to talk about the project itself and what I like to do in terms of saving that data out. So if you start ExScan and you don't have a scanner hooked up, it's going to tell you that the device is offline. But in order to get our project back, we actually need to go into scan mode. And again, you can see here, the graphics card in this machine is not supported. And I've done a scan with it before. And what I found is that it goes through the calibration okay, but when you actually try to push the computer, that's when it starts to fail. It doesn't really matter what we select at this point because we don't have a scanner hooked up, but what we're going to do is we're going to open a project group. Now I need to find the project group that I'm going to be using, and this is where saving the data comes in handy. When you create a project, when you start a new project group and you start saving those scans, that data is going to go into a folder in whatever location you saved it. Now, in my case, what I like to do is I like to take that entire folder, copy it and paste it in another location. This preserves all of the raw scan data without any modification. So as we start to get into processing the scan data, you'll notice that as soon as we delete points from the point cloud, we are not going to be able to get those back. So the first step for me is always going to be to copy that entire folder as sort of a safety save. So I'm going to come in here, I'm going to select the SLNRAP. That is going to be the project file, the overall project file, and we're going to open that up. Now, what you might find when you do this is that it's not going to load all of the different scans. You might find that it only loads one of the scans. In our case, for the rapid scan, we had 4. Again, it's telling me the device is offline. I don't really care about that. If you happen to open yours up and it doesn't include all of the scans that you've done that you know that are in that project, all you need to do is add another scan and using this open project setting. So if we select open project, you can go in and find the different projects, project 1, 2, 3, 4 in this case, and you can include those inside of your project group. For me, it actually opened up because I opened up these scans before. So now you can see that we've got all 4 in here. They're out of order. We can toggle them on and off as needed, and we can review the projects and determine what we want to do with this data. Now, the first thing I will say with this scan data is that we have a lot of markers. Now, as I mentioned during the process of scanning, I added way more markers than you actually need. And in this case, it's overkill. I know it's overkill, but what I found was I scanned the entire fender using feature alignment and was able to do it if I moved really slow and it didn't skip around. It was able to still keep track of all those features, and I got a pretty good scan out of it. What I found when I started to use the hybrid alignment with the markers on this car, because it has large flat areas, it was actually losing tracking quite a bit. And I'm not sure exactly what the problem is, maybe if it was lighting or the brightness setting or something, but it was losing tracking and it kept telling me that it needed markers for alignment. And I kept adding more and more markers until I got to the point where I no longer got that warning. So in certain areas, there are a lot of markers. You can see them here. And anytime you have markers that are close together, that's actually going to be problematic. For example, these markers here, where we don't have enough data around the outside, when it removes these, it's not going to be able to patch that. So these are all things that we need to be careful of when we're placing markers. I'm going to do another video that's going to talk about feature alignment versus markers versus hybrid, and we're going to play around with the number of markers we need to get the results that we're looking for. But just keep that in mind that there are quite a bit on this fender. And one thing I did notice with rapid scan that was different than the handheld HD scan is we actually got a lot of double markers. So these double markers in these large flat areas where there was really no features, even though I had a lot of randomly placed unique markers, it ended up looking like it double counted markers in some cases. Now, overall, the scan is fine. It looks like it's fine, but it will have problems removing these as markers because it doesn't treat it the same as it does a single marker dot for some reason. So that's just something that we need to keep in mind as well. All right, so now that we're here, the first thing that I want to do is I want to align these scans. So we need to select the align option, and we need to pick a project that's going to be in the fixed window, and we need to select the alignment type. Because we have markers, we're going to use by markers. That is by far the most efficient way to do this. So I'm going to select project 1, which was the fender, and in the floating window, I'm going to select project 2. Because we're using marker alignment, we don't have to manually pick points on either scan. If you happen to be using the manual alignment feature, you'll need to pick at least 3 points on both scans in roughly the same location, and it'll go through and it'll try to calculate their positions and align them. Now here you can see that we've got a pretty good alignment. We can rotate this around and we can take a look. There is some overlap. So you can see that there is actually a slight shift or difference in some of these features because this is a driving light and the turn signal or marker light. Because that data isn't really important to me, it's just a visual reference, I don't really care that there was a shift there, but these are the kinds of things that you want to look for, and these two should be overlapping, and you can see that the green section here, there's actually a slight shift in that as well. So what that tells me is there was good alignment in some areas. We can see where the fender rolls over. That looks like it aligns pretty well. The pop-up aligns pretty well, but this feature got shifted and lost. And that's pretty reasonable because whenever you have a consistent long feature like this, especially since it's a clear lens, I put tracking markers on there, but you can see that the markers actually were double counted again. That is going to be the distance that they were shifted one way or the other. Now, it probably happened after a pause in the scan and a rescan of that area. But again, I'm not too concerned. What I'm going to do is I'm going to cut away some of this, but I can select next, and it's going to put those two together. Now, at this point, it's also important to note that we put those two together, but they are not going to be merged just yet until we mesh them. So we can still do some processing. We originally scanned the header panel and the bumper, but I actually don't think I need any more data. It's just going to add more points and more clutter. So for now, I'm going to select exit. And note that project 3 and project 4 aren't going to be used at all. So what I want to do is right click and select remove to remove project 3. And then I'm going to remove project 4. Now there is an option to delete the project, but I don't want to do that. For project 4 and project 3, I'm going to remove them simply because all that does is it removes it from our project group here. But if we wanted to add them back, project 3 and project 4 are still saved inside of that same folder location. I could bring them back at any point in time. If you delete them, it's going to remove them from that project folder and you won't be able to get that data back. So again, it's just another way to sort of be consistent with the data. Now, anytime we have an overlap in scan, this is an area where we potentially are going to have some problems. You'll notice that the marker alignment looks a bit shifted in a few of these areas. So what I'm going to do is I want to make sure that I only keep the data that is going to be important. Remember, when you select a project, it's going to highlight in blue. So what we want to do is we want to edit project 2. Now project 2 has a lot of extra data and you can see it's a bit noisy on the edges. We want to delete that. So I'm going to use my polygon selection and I am going to, remember we have to hold down the control key and I'm going to start drawing these areas. Mistake. Remember, we have to hold down the shift key and I'm going to start drawing along the hood line. And another thing that we should consider is that by default, we have select through turned on. We are actually going to be selecting everything through the scan. So if I rotate this around, you can see that we grabbed part of the bumper. Now, if we show project 1, we have a lot of that bumper data there, so we don't necessarily need it for project 2. So we could get rid of that if we wanted to. But once we select that area, we're going to select delete. Nothing has happened yet. We can still undo it. But as soon as we select apply edit, that data is going to be gone. So once again, holding down shift, I am going to get rid of some of this bumper because I don't need it. And then I'm going to delete that data. So once I'm happy with the data that has been deleted, I simply select apply edit. And this is the point where all the points that we captured in the scan are going to be gone. As far as I know, there is no way to get that data back. Now, if we did the save as an ASC file, that would capture all of those points as a raw file. Now, those ASC files can be opened in MeshLab, which is a free mesh software. Apparently, it cannot be opened in GeoMagick. So I'm not sure which software can open it and which can't. ExScan cannot reopen that ASC file, so it's just kind of a safety save. Now that we've removed that, let's go ahead and just take a look at project 1 and maybe clean up the edge a little bit. So when we have a scan and we have this sort of jagged scan on the edge, that is going to potentially cause us a problem. So we just want to make sure that we do have enough. Because this is not really an area of interest to me, I only really care about the fender. All the rest of that is just a reference. I'm not going to be too worried about it. I'm just going to leave it as is. Also note that we do have a ridge in the midline of the scan. It's kind of hard to see right now, but it is there. It is on the bumper and it is on the hood, even though it's very faint on these cars. That is going to be where we mirror this over, but Fusion 360 cannot mirror the mesh body. It's not going to be able to do that for us like we would a normal solid or a surface. So that is something that if we decide downstream to do that, we'll have to do it in another software. Now, Fusion does pretty good at handling mesh data, but there is, of course, a limit. Now, the limit is going to be in the number of total points. In our case, is over 2 million points between these two projects. That's quite a bit. It will actually drag Fusion down a little bit when we start to play around with it. There are some things that we can do to help that, but that is going to be problematic. But at this point, we're happy with everything we did. However, we need to generate the point clouds again. Now, by generating the point clouds again, it's going to take the data that we removed and it's going to sort of solidify that as the scan. So in each project, I'm going to right click and I want to make sure that the generate point clouds is grayed out. So project 2, for example, make sure that that's grayed out and make sure that that data is generated. Now, once we're happy with all of those, we're going to move on to meshing the model. Now, meshing the model is going to combine all the scans that we aligned, and it's going to put it together in a true mesh. This is going to be triangular faces or facets. There are a couple things that we want to make sure that we do here. We want to make sure we allow it to do the marker hole filling. I'm going to guess that it's not going to be able to get all of them because we did have some of those double markers on the hood, but we do want to make sure that we allow it to do that marker hole filling, allow it to remove spikes if possible. We can let it fill small holes, and we can also limit the max number of triangles. So if you're taking something to Fusion and you are trying to, let's say, convert it, then you might be very interested in limiting those max number of triangles. I'm going to leave all the settings as default. But we do also have the smooth option. We can toggle the smooth on to low, medium, or high. And what that's going to do is it's going to take the points and sort of average them in the surrounding areas. So I'm going to put the smooth option on medium. I'm going to leave the filter to low, and all the rest of the settings, I'm going to select apply, allow it to go through meshing that data, and see how many of those marker holes we were able to fill. Now, as I mentioned before, the computer I used to scan was a laptop. It's different than the machine that I'm filming this on right now. The machine that I'm using now has a much faster processor, but a much lower graphics card. So I don't quite have as many CUDA cores. It doesn't really have the same GPU. But what I've noticed is the laptop ExScan was having trouble utilizing the GPU. But here on the computer that I'm using, even with the much lower graphics card, it's able to access the GPU because it's not feeding it through the onboard GPU or the onboard graphics card in the laptop. So if you find that you're having that problem, make sure that you double check your specs. The laptop I'm using was a great laptop in 2017. It is a bit out of date now, but it does still have enough specs to handle it. So you can see here, it did a pretty good job. Obviously, there's a double hole here that we need to fix. The markers down here ended up being little bumps. That's something that we need to fix. And the hood, it absolutely did not do very well on the hood. Now you'll notice the areas where it overlapped, we can see that there are bumps and some of the holes just didn't get filled. We can reapply this. For example, we can increase the small hole perimeter. Let's take it up to, let's say 20 millimeters, almost an inch. That should cover these, and reapply it. It's going to go through, it's going to remesh all the data that we have, and it's going to try or attempt to fill those holes on the hood. Now, this is one issue or area where I didn't run into the problem when we were doing the handheld HD scan. I didn't see any of those double markers, but with the handheld rapid scan, remember we're going from 10 frames a second to 30 frames a second, but we're capturing half of the amount of points in that same second. So we are capturing more data, we're bringing it in quite a bit quicker, but it is less data coming in. And because of that, I did notice, whether it was my fault, whether it was how I was moving, I did end up seeing those double markers on the hood, on that header panel, and on the bumper. Those are going to cause downstream issues. What I suggest is if you're scanning and you see those double markers, delete the scan in the project and start a new scan. Because you can see here downstream, we're just going to have problems. So what I'm going to do is I'm going to confirm this. Again, the main area that I'm interested in is the fender. So what I can do is I can manually take care of that data, and I'm not going to have you sit through that process, but what I'm going to do is we're going to show you how to do that, and then I'm just going to jump ahead until after it's done. So you can see here that the manual hole filling is picking 241 holes, and it says 0 holes filled because we need to go through and manually select the holes that we want to fill. And this is why I'm not going to subject you to sitting here and watching this. Once again, I have noticed that ExScan seems to really like a higher processor speed over memory, over the graphics card. Now, again, a much lower graphics card spec. I mean, I think this one is maybe a $300 graphics card in this machine. It is an NVIDIA Quadro series, but it is very, very low spec. And it is using almost all of it here. It hasn't tapped it out. On the laptop, it never went above 7% on the GPU. So take that for whatever it's worth. CPU usage is relatively low, and memory usage is relatively low as well. So at this point, what I'm going to do is I am going to pause the video, and I'm going to jump ahead until I have all of these holes selected, and then we're going to touch back in on how to fill them all in. Okay, so I now have selected all of those holes, and what we're going to do is we're going to select confirm, allow it to go through the hole filling process, and then we should have a nice clean mesh where all those holes are filled in. I will say that when we go back and look at this with edges turned on in Fusion 360, we are going to notice where those holes were filled. The mesh is going to be different. Now, in the areas where it actually was able to fill, this hood is in not perfect condition by any means. There was rust, and you can kind of see a little bulge here where in real life you can't really tell as much, but these corners had some rust on them, and they just have some body filler in them right now. But you can see in the areas where it had double markers that it was able to fill. Those are going to be problems that we need to take care of. There are some bumps that are down here that we need to take care of. And what we're going to do is I'm going to show you how to fill some of these, and then I'm going to go ahead and take care of some of the other ones on the hood. So again, the process doesn't really need to be different. It's going to be the same no matter what you do. So we'll take care of the ones down here. I'll show you that, and then I'll take care of the rest. So I'm going to change to the paintbrush. And again, if we hold down Control, that is a deselection, and Shift is a selection. You can use the mouse wheel to change the size. So for example, if I select that area and then I hold down Control, I can deselect it and I can paint it over that. What I'm going to do is I'm going to reduce that size. I don't want to take away more than I need, but I'm just going to select the areas that have sort of these bumps on them. And I'm even going to clean this up because I'm not going to have that sort of parking lot bumper on my my fender flare. And I might even clean up that little dent right there. And once have everything selected, I'm going to delete the selected area. And then we need to go back to manual hole filling. So once those areas are gone, the manual hole filling is going to allow us to sort of fill those in. I'm going to undo that right there. And we'll go through it again because I accidentally hit undo. So again, just select those areas, go through and clean up the areas that you want. Keeping in mind what you're actually doing is you're selecting a mesh underneath here. So you are going to get triangles. So I'm going to deselect that right there because I don't want it to be too close to the edge. I'm trying to be really careful in this area because it is right next to an edge, a transition. But I am going to delete those and I'm going to apply the edit. Again, it's going to process it. Once we apply that edit and remove those, we are not going to be able to get that data back. But now I'm going to select these areas. It's going to fill it in based on curvature. So hopefully it doesn't mess up that edge. It's not really important to us. The main areas where we are going to connect to this mesh are going to be along this bumper line. I'm going to keep the stock bumper, and I'm only going to make an over fender that sort of attaches to that stock location. I like that look. I like sort of maintaining that. Now, if you don't know anything about these cars, which not a ton of people do, they were made in the US at least. They were brought in 83 to 89. And 83 to 87, they had what's called the narrow body, which is this style. And in 86, they introduced a wide body, which ran until 89. Mostly the same car underneath. The wide body fenders actually bolt here. On the rear of the car, I would need to cut and do some welding from a donor car. And I don't want to just have this car look like that. I like the look of these fenders. So it has a very different look to it than the wide body does. So the plan is to create a wide body version that still maintains the same sort of transition and shape to a rounded lip, but is bulged out a bit. So that's part of the reason why I am doing sort of a custom wide body here. So now I'm going to take care of these other areas. And once again, I'm not going to subject you to that because it's just the same as we did before, just selecting the areas you want to remove and then using hole filling. So I'm going to take care of these and we'll check back in after they're taken care of and we'll move on to the next step. Okay, so most everything is filled. There is an exception, and in this area of the bumper, so what I did was, this is where the seam is between the two scans, and it was noticeable. You can kind of see it down here through the rest of the bumper where the driving light is. And what I did was I deleted that area, hoping to patch it. And this is something that happens quite often. You remove an area and you go to patch it, and it just doesn't quite look right. You can see there's a dip in the bumper here. And again, once we confirm those, we can't go back. To the best of my knowledge, we're stuck with these. It is a direct modeling approach. But there are a couple different filling types. We've got curvature based, which is great if you're just removing a small hole. You've got tangent based, and you've got flat. Now, if we select this and we try to do a flat fill, you can see that it's rolling around these edges. It's not giving us a good fit. I'm going to redo that. I'm going to try tangent, see if this gives me a better fit. And you can see it looks a little bit better. We still have some problems here. I'm going to reset it and try curvature and see if one gives me a better selection over the other. So what is probably a better approach to this, and it's something unfortunately I can't go back and change. What a better approach to this would be is to remove a small area, patch it, remove a small area, patch it, and then remove a small area again. At this point, we're going to be kind of stuck with it. Again, it's just a visual reference, so it's not really a big deal, but it is something that just can't quite be fixed at this point. But once again, the only areas that we really need are going to be the fenders. You can see there's a little dot here. This is going to be tricky, again, because of its proximity to these edges. But once we apply the edit, we're going to be stuck with it. So again, be very careful when you're making these changes. Make sure that you are selecting geometry and you're not going too close to edges, because you can see how far the patch goes. It essentially takes the hole that you have and it takes a certain amount of surrounding geometry, certain triangles, to patch that hole. So this looks like it's okay, but we can tell that it did eat into this corner just a little bit. And these are things that we just have to be careful and mindful of. So everything looks pretty good. One other thing that you can do if you have dents in the scan, so these header panels are very thin. They're notorious for getting dented. We could try to remove geometry and start to fill those back in. Not really a good idea to do here. One, because we don't really need it for what we're doing with the fender. The fender was the main area, and that, especially in the area that I need, so this area right here looks really good, and back where it meets the door looks really good. That little section there, I'm not really too worried about. It's important when we start to design a fender flare or anything off the mesh. We're not going to have a ton of divisions and match the mesh exactly, so we can skip over that area just fine. It is problematic that I don't have the bottom section here, and that's because it was rusty, because it was black, but that's okay because we can sort of work around that. But keep in mind that we don't have that data down there, partially because of access to it, lighting, because of the fact that it was a little bit rusty in that area, the fact that it was black. But again, that's okay. I'm not too worried about it for what we're doing here, because I'm going to assume that nobody watching this is going to be building a fender flare for a Starion. You just want to understand the process. So once we're done with the mesh edits and we're happy with that, the next step is to move on to the measurement. But before we do that, it's important to note that we can export it to a third-party software. So if you happen to be using DesignX or Geomagic Essentials, or you want to send this straight to Solid Edge, for example, you could do that from here, and you could do additional processing of the mesh in those softwares. So if you're going to do your alignment in Geomagic, then you can certainly do that. We also have the Save Your Scan option. At this point, it lets us save, again, the ASC file, which will be the scan data as we have it. We can save an STL, an OBJ, a PLY, a 3MF. All those can be done here. I'm not going to save them yet at this point because I still want to do the alignment, but it's important that we consider what we've done and make sure that we've processed the mesh at this point completely to our liking. And again, because I'm only interested in the fender, the rest of the stuff is just a visual reference for the look of it. I just want to make sure that the fender area that I need, so again, in this area where it meets up with the bumper and the air dam, I want to make sure that those are okay. And I want to make sure that back here, that data is okay. And everything looks good for what I need. Once again, I could remove that bumper, not going to worry about it, just because it's extra time that we don't need to worry about. The tire I'm going to leave, really don't need to, because it's just kind of extra mesh, but I'm going to leave that in just for visual reference for now. The next step in this process is a little misleading, but we're going to go to the measurement section. Now, measurement does allow us to do things like measure. So if you want to check the accuracy of your scan, in this case, a large car fender, or rather small car compared to today's standards, but measuring a part like this doesn't really make a whole lot of sense. So I am not going to worry about the measurement tools in this video. When we do scanning of more mechanical parts, we'll take a look at that. But what we do want to talk about are the two sections called create feature and movement. Now, again, these are a little bit misleading. Create feature looks like we've got cylinders, spheres, and triangular or cylindrical cones. What we're going to be doing is creating features like planes, axes, and points. And then we're going to use movement to align those planes, axes, and points built off of the scan to the coordinate system. And that means that when we save out our mesh, it's going to be aligned for us. Now, the trick to this is that we really don't have great references. Now, if you're scanning a mechanical part that's got machined faces, then you obviously have planes. You've got geometry like bolt holes where you can create points. That is a much easier task to align. For us, we have to get a little creative. So what I'm going to do is I'm going to create some features. And there are a couple different ways that we can do this. Points can be based on line plane intersections or just a selection. The lines can be based on point to point, again, a selection directly on the mesh, or plane intersections. And planes can be based on 3 points. We can do a point line fit or a best fit based on selected geometry. So the best fit based on selected geometry works well if you've scanned a plane or you scanned a machined face of a part. For us, the 3-point fit is probably going to be the best option. And what we're going to do is we're going to base this off of the ridge in the center of the car. So it's a bit tricky and it's not going to be perfect, but by selecting those points, I can create a plane that represents the midline of the car. Now, it's going to be important to me because when I create or move this to my coordinate system, I want the midline of the car to be at 0. So the next thing that I want to do is I'm going to create a point, and this point again is going to be the center reference for me where the coordinate system is. So I just need to select a point on the midline. This could be done by looking at a plane-plane intersection, or line-plane intersection. And again, what I'm going to do is I'm just going to select a point, and I'm going to rotate it around until the lighting is just right, and try to select a point that is on that midline. So that point is going to be the location of XYZ0. The plane is going to be used as a normal reference, and then we also need a line which is going to represent X, Y, or Z. So the line is the trickiest one for us because while this is a boxy scan, a boxy car, things still aren't straight. So the bumper is not straight, it still kind of arcs in. The sides, while they are very boxy, they are not straight. So this is a very tricky one for us to get right. After we do this, we do have some options to do things manually, but we need to think about potentially the best reference for a line. And I think on this car, the best reference for that line is actually this hood opening. That does point pretty well in line with the coordinate system. So what I'm going to do is do a point, and I am going to try to get them relatively close. So while this does represent a line, now that I think about it before I make that selection, when we look at it from the front, that line, that's horrible. Let's go ahead and rotate this around. When we look at it from the front, that line is not straight, but this one is a bit closer to straight, but it is still angled in the other view. So this means that I'm just going to have to visually pick what straight is. So what I'm going to do is I am going to pick 2 points on the license plate. I'm going to try to get the upper edge of the license plate because that is flat, and see if I can't get a reference off of that. So again, not ideal, but it will allow me to create that line. All right, so now that we have a point, a plane, and a line, we have everything we need to use movement with the 3-2-1 system movement. So with the 3-2-1 system movement, we're essentially looking at 3 points on a plane, 2 points on a line, and 1 point, which is a point. And we can choose how that's constrained, and we can undo this at any time. But we've only got one of each, so plane, line, and point. And you'll notice that the move option doesn't come up. The constrained point is not actually in here because I never actually okayed the creation. So inside of our feature list, we have our line and our plane, but the point never got created. So let's go ahead, do our selected point. I'm going to pick where I want XYZ0 to be, and then again, roughly centered, and then select create, and then close. So if you forget to do that, you can always go back and forth, but now we've got plane 1, we've got line 1, and we should have point 1 in here. So I'm going to select move, and when we move this, you'll notice that the coordinate system is not great. The coordinate system does not look right. We can change X and Y, and we can move it and reset it. But what this tells me is that the references that I'm using are just not going to work. So this tells me that I need to rethink either my line or I need to rethink my plane. The point is fine. The point really isn't going to matter as long as it's on the midline. Again, we can change X and Y references, but when I look at this from the front, that obviously is not aligned. So I'm going to close this out. I'm going to go back into those features. Go ahead and rotate this thing around and move it back to center. And I'm going to create a couple more features. Now, at this point, I'm not going to subject you to this process because I don't have a good reference on the car. So it's going to take a bit of trial and error. So what I'm going to do is I'm going to pause it, and then we'll check back in once I have a result. Okay, so I made a new plane based off the bottom edge of the air dam, which is parallel to the ground. And I made a new line based off vertical references in the tag bracket. So this gets me closer. It's still not perfect, but it's relatively close. What I want to do before I okay this is I want to make some adjustments to what Z and X are. So I'm going to say that this is Z plus, move it, which flips the car over. And I'm going to say that this is Y plus. So now when we look at it from our front view, the car is pointing to the right and Z is pointing up. Now, if this isn't perfect, if this isn't accurate, we still have the exact movement options, which allow us to move and rotate it based on these inputs. So this is relatively close. And what I want to do is I want to rotate the car about Z. I'm going to try 2 degrees, select move 2. I'm going to go the other direction, so -2, and let's say maybe -4. What I'm looking to do is orient this based on what I expect to see looking at the front of the car. Now, if you've never done this before, if you have a reference when you create your scan, it is going to be a much better situation, because if I had scanned, let's say, a plane on the floor, if I'd laid down some cardboard or something and had tape lines where X and Y are, that would give me a great reference. I do have things like the ES logo, which I could potentially use for a vertical line reference, or these bumpers on this car are horizontal with the line, so I could have potentially picked up on some of that. However, those are not true lines in the sense that they're pointing along the Y-axis. So again, having those references is important. Looking from the side now, I want to rotate this about X. And if I go down, let's say 3 degrees, what I'm looking to see is Y pointing along this line right here. So if we zoom out, we want to see Y is along that feature on the car, because that is horizontal on this car. So Y should be pointing completely horizontal on the car. If I rotate around to a front view, this should look okay from the front. If I rotate around to a top view, it is okay, but we can see that it could potentially rotate about Z less than it is. So I'm going to rotate this down to, let's say, 5 degrees, and that looks a bit more realistic. So from the front view, that looks about right. From the side view, that looks about right. Now, once again, these are all going to be visual because the part we're designing really only needs to be based off of the scan data of the fender. The main reason that we're doing this, well, the 2 main reasons that we're doing this. One is so that when we import it into Fusion, the orientation is correct relative to our coordinate system. That's important for visual references, for for rendering and so on. But the second thing is that when we're manipulating a form body, we're doing it based on the coordinate system of the part. So X, Y, and Z directions are going to be important to us in that regard. So now that we have this, I'm going to select close. And this means that we've taken our point cloud, we have aligned two scans, we removed two of them that we ended up not needing. We aligned two scans, we manipulated the point cloud data by removing some of it before we converted it to a mesh. Once it was converted to a mesh, we then went back and manipulated that mesh data. We filled holes, we smoothed out some areas, we allowed it to process the mesh and do some level of smoothing across the entire thing to make sure that we have a good result. There are some areas that are still potentially problematic. This dent is on the actual fender, and because it goes right up to that corner, it'd be problematic to try to remove. But all I really care about is this front edge. And because the end goal for me is to 3D print this fender in parts, attach it to the fender on the car, and then build a fiberglass mold off of that, I don't need it to be perfect because all of those other processes are going to introduce dimensional inaccuracies. As soon as we go to 3D print this, we'll be able to see if it fits the car, and hopefully that is going to fit pretty well. Once we get to the fiberglass stage, the fiberglass over a part this big, it really only needs to attach at this section of the car, and the rest of it doesn't, it can flex around a bit. But we need to think about those things when we're designing our parts. At this point, I'm pretty happy with everything that we've done. We can worry about the rest of it downstream as long as we're happy here. Now, important note, if you do come back to the handheld rapid scan, you reopen the project, you can go through the entire meshing process again. At this point, nothing that we have done, the meshing part, has not been saved in the project. It's saved out as an STL or an OBJ or a 3MF, but it's not contained in the project in ExScan. So keep that in mind that everything we've done at this point can be lost as soon as we close the software. So you do want to make sure you save it out. If you reopen your project, any of the manipulations that we did to the point clouds, those are going to be saved into that project, but the alignment data, that's saved in the project, but the mesh portion of it is not saved. So at this stage, we want to save our scan. What I'm going to do is I'm going to pick the right location, and I'm going to save mine out as an STL, an OBJ, and a 3MF. There's no reason for me not to save all three formats, just to have a different format to try and play with. So I need to find the right location. And once I have the location, I'm going to call this Starion front aligned. We'll save that, and that way we can bring that data into Fusion. Now you can see here it tells me only letters and numbers for OBJ file. That means it does not like spaces. If you don't save as an OBJ file, then you might not have to worry about that. But since I am picking those three formats, I am going to do Starion front aligned. You can also save it as an ASC file if you want. Once we select that, you can see that we can scale it up or down here. The size really doesn't have a great reference for me because it's not based on a specific feature. It's the overall scan data, including parts of the A pillar and all that stuff. But the scale should be perfectly fine. I'm just going to say 100% and save it out. Once we have the scan saved, now we could take that data into Fusion 360 and begin designing our fender flare. If you have any questions on the process at this point, please let me know. At the end of the series, I do plan on doing a more quick overview of ExScan, of the scanning process, and the overall process of just getting to that mesh data part. But at this point, I want to include everything that's being done from the HD scan to the rapid scan to the entire process with the exception of the monotonous clicks for all the holes. But I want to make sure that we include all of that so there is no part in the process that is sort of black magic. We want to make sure that we go through all of it in length. So that way anybody that's trying to do this for the first time can do the same thing. But if you have any questions, please let me know. If you do use ExScan and have any tips, please leave them in the comments. I can pin those comments for anybody looking. This is really my first go and my first project going through ExScan and using the EinScan the Pro HD in this case. So it's my first time through using all of these tools. So hopefully I covered everything clear enough and it makes sense. But if not, obviously please let me know. I do plan again on going back through and doing a more abbreviated version of all these videos. So once again, thanks for watching, and we'll see you in the next one.